Welcome to this video on the Automic Automation Oracle OCI integration solution. In this video, we will explain the Oracle OCI integration and what it brings to the Automic Automation user community. Oracle Cloud Infrastructure, OCI, is a cloud platform for running databases, services, and applications. Oracle Integration Cloud, OIC, is a service within OCI that streamlines the connectivity between cloud-based and on-premises applications. OIC enables seamless integration of various applications, utilizing the resources and infrastructure provided by OCI. Integrating Automic Automation with Oracle OCI allows you to start integrations in your Oracle OCI workspace from Automic Automation. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the configuration of the agent and the design of the two core object templates, connections, and jobs. Finally, we'll run through a demo. Automic Automation plays a central role in orchestrating operations across multiple environments, including the cloud. Automic Automation synchronizes these processes with other, non-cloud operations. By integrating Oracle OCI, we can configure process automation centrally in Automic Automation and then trigger, monitor, and supervise everything in one place. Oracle OCI processes can then be synchronized with all other environments routinely supported by Automic Automation. Oracle OCI's role is reduced to execute the jobs. All other functions, especially those pertaining to automation, are delegated to Automic Automation. This means that we don't have to log into the Oracle OCI environment and keep on refreshing it by ourselves. Automic Automation manages all the execution and monitoring aspects. The Automic Automation integration provides a simplified view to start integration jobs. Automic Automation lets us build configurations with intuitive interfaces like drag-and-drop workflows and supervised processes in simple dashboard tools designed natively for operations. Statuses are color-coded, and retrieving logs is done with a basic right-click. From an operations perspective, Automic Automation highly simplifies the configuration and orchestration of Oracle OCI jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workload. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workload. A conventional architecture involves two systems, the Automic Automation host and a dedicated system for the agent. The agent is configured with a simple INI file containing standard values: system, agent name, connection, and TLS. When we start the agent, it connects to the engine and it adds two new objects to the repository: a connection object to store the Oracle OCI endpoint and login data, and a job template designed to trigger start integration jobs. Let's assume we're automating for 4 instances of Oracle OCI. We create a connection object in Automic Automation for each instance by duplicating the con template for each of these instances. Lastly, we create the start integration jobs in Automic Automation for each corresponding process in Oracle OCI. The Automic Automation jobs include the connection object based on the target system. When we execute the jobs in Automic Automation, it triggers the corresponding process in Oracle OCI. We're able to retrieve the successive statuses and finally generate a job report. In Automic Automation, this job can be incorporated in workflows and integrated with other, non-cloud processes. The procedure to deploy the Oracle OCI integration is as follows. First, we download the integration package from Marketplace. This package contains all the necessary elements. We unzip this package, which produces a directory containing the agent, the INI configuration files, and several other items, like the start command. We use the appropriate INI file for our specific platform. Oracle OCI is a standard Automic agent. It requires at least 4 values to be updated: agent name, atomic system, JCP connection and TLS port, and finally TLS certificate. When the agent is configured, we start it. New object templates are deployed. We create a connection to every Oracle OCI instance we need to support. For this, we use the template con object, which we duplicate as many times as we need. The con object references the Oracle OCI endpoint. Finally, we use the Oracle OCI template job to create the jobs we need. We match these atomic automation jobs to the Oracle OCI start integration jobs, reference the connection object, and run it. We're able to supervise the jobs, generate logs, and retrieve the statuses. The jobs can then be incorporated into non-cloud workflows. We install, configure, and start an agent to deploy the Oracle OCI integration. The agent is included in the Oracle OCI package, which we download from Marketplace. We unzip the package, which creates a file system agents/Oracle OCI/bin that contains the agent files. Based on the platform, we rename the agent configuration file UCXJCIDX and set a minimum of 4 values: the agent name, the AE system name, the host name and port connection to the automation engine's JCP, and finally the directory containing the TLS certificate. Finally, we start the agent by invoking the JR file via the Java command. The agent connects to the AE and deploys the object templates needed to support the integration, the con or connection object, and the Oracle OCI start integration job. In our demo, we will create a connection object. Once we have established the connection to the Oracle OCI environment, we'll create a start integration job. Finally, we'll execute and supervise the job. Let's start with the demo. In the OCI console, you can find a wide range of integrations to choose from. If you wish to customize your integration style, simply click the Create button. In the world of integration, there are various options available. Let's take a closer look at the available integration options. First up, we have App-Driven Orchestration. This option is perfect for handling complex multi-step integration flows, allowing you to connect applications and data seamlessly. Next, we have Scheduled Orchestration. This option is ideal for setting up time-based triggers for your integrations, ensuring that your workflows run smoothly on schedule. Moving on to File Transfers, this option is crucial in moving files across networks efficiently, ensuring secure and seamless data transfer. Basic Routing simplifies application-to-application routing with its data mapping capabilities, making it easy to manage your data flow. You can easily publish messages from your applications on an OCI publish or subscribe channel, facilitating efficient communication within OCI. Finally, don't forget to subscribe to messages from OCI publish or subscribe channels to stay connected and informed. These integration options allow for streamlining workflows and enhancing productivity within the Oracle Cloud environment. Let's dive deeper into one integration within the Oracle Cloud. By clicking on an instance, you can view a graphical representation of its execution. In the integration, scheduling automates task execution, while the wait action parameter controls the execution flow by specifying the wait time before proceeding to the next action. The Properties tab provides essential details, and the Action Report tab shows the count of actions taken. After a 10-second delay, the integration transitions to the stop state. Let's move on to the Automic system. Here, we create a connection object with specific inputs to connect to Oracle OCI. We must enter the endpoint, which is the URL that points to where the Oracle integration services are running. Next, we specify the authentication type. Currently, the OCI agent integration supports the OAuth 2 authentication. The next set of parameters refers specifically to the OAuth 2 authentication and is obligatory. The authentication endpoint defines the URL of the authentication server, which clients call to request the authentication token. The client ID is the identifier defined in your OAuth 2 system, and the client secret is the encrypted secret value specified in your OAuth 2 system. The OAuth 2 field is already filled in, as the connection object currently supports OAuth 2 version 1.0 only. The next parameter is the resource parameter, which specifies the range of applications to which the token will grant access. The last parameter is the OCI version, where you can use v2 and v3. For v3, you must additionally define the integration instance. If you are using a proxy in your environment, you can specify the proxy hostname, port, username, and password in the proxy section. Now, let's define the parameters for a start integration job. First, we have the connection object. Here we have already defined one. Next, define the relevant integration in the integration name field. You can enter the name directly or click the Browse button to the right of the field to open a picker dialog with all the integrations available on Oracle Cloud. The integration name also includes the integration version separated by a pipe character, thus allowing for unique identification on the Oracle Cloud integration platform. You can use the filter function to narrow down the list of integrations, which, for example, is especially useful for finding integrations with failed in their name. Resetting the filter displays the complete list of integrations again. Next, we have the integration payload parameters. Suppose your integration on the Oracle Cloud integration side requires a payload. In that case, you can provide it in two ways. Specify a file path containing the parameters or directly input a JSON payload definition here. In our example, the integration payload option is set to none for demonstration purposes, indicating that no payload is being used for this integration. Let's execute the job and open its reports after it has ended. The agent log shows all the parameters used to run the job and the execution results, which helps troubleshoot possible issues if they occur. It also shows the final URL for the integration process and the different states the job passed during its execution. Finally, we see that our job has ended with the status completed. The report shows the final state and captures the information the target system sends to Automic Automation when the job has run. Now, let's look at the job status in the Oracle OCI instance. The integration task was scheduled, triggered, and successfully completed in 11 seconds. Now, clicking on this instance shows a graphical representation of the task execution. That wraps up the demo on how Automic Automation can integrate with Oracle OCI to execute and monitor various jobs. Thank you for watching this video.